Good evening students, welcome to Basic Electrical Lectures, Module 2, Single Phase AC Circuits, and it is class number 3. In class number 1 we studied pure resistive circuit, in class number 2 pure inductive circuit is covered, and in this lecture I am going to explain that is pure capacitive circuit. So we can start. What do you mean by pure capacitive circuit? Yes, it is the circuit consists only capacitance is called pure capacitive circuit. We can draw the pure capacitive circuit diagram. So now the capacitor is connected across the supply voltage. So I am writing instantaneous voltage V is equal to Vm sin omega t capacitor, and then current is flowing. See, this voltage source drives the current. When our current flow to the capacitor is going to charge. Okay. So the capacitor is going to store the energy in the form of electrostatic fields. So we know that basics, the instantaneous charge can be written as Q is equal to C into V. Now Q is equal to C. Substitute V this equation. What is V? Vm sin omega t. Now we know that what is the definition of current? I is equal to rate of flow of charge is nothing but current. I is equal to dq by dt. Now I equals to substitute the value of Q here. Substitute Q value here. Therefore, we can write I is equal to d by dt. What is Q? C into Vm into sin omega t. Okay. Now I is equal to C Vm d by dt sin omega t. Now differentiate sin omega t with respect to dt. So if I differentiate that, what you will get? Omega into cos omega t. C Vm omega into cos omega t. So write in correct order. So omega C Vm into cos omega t. So we know the trigonometric relation. What is cos theta? Cos theta is equal to sin theta plus 90 degree. Cos theta is sin theta plus 90. So similarly, in place of theta what we have? Omega t. Therefore we can write sin omega t plus pi by 2. Since this is in radian, we have to write pi by 2. Now apply this relation over, replace cos omega t by this equation, and along with that, modify the current equation in this way. Omega c Vm, I am modifying this term in this way. That is Vm over divided by 1 by omega c into sin, replacing cos omega t by this equation, sin omega t plus pi by 2. Okay. What is, if you simplify this, you will get same equation, omega c Vm. But what is 1 by omega c? Capacitive reactance. Very good. 1 upon omega c is nothing but capacitive reactance. So the unit of capacitive reactance is ohms. What is omega value? 2 pi f. So 2 pi f into c is equal to what? Xc, capacitive reactance. Its unit is ohms. Therefore now I can write I is equal to Vm divided by, what is 1 by omega c? Xc into sin omega t plus pi by 2. So further, what is Vm by Xc? I can write maximum current. I is equal to, so what is Vm by Xc? Xc is in ohms, voltage by ohms, current. So therefore I is equal to Im sin omega t plus pi by 2 amperes. So this much current is flowing in the capacitor. So if I apply voltage to the capacitor Vm sin omega t, the current flowing through the capacitor is Im sin omega t plus pi by 2. See, with respect to voltage, what is your current? Current plus means leading. Current leads the voltage by 90 degree or pi by 2. This current will going to lead this reference voltage by 90 degrees at all the instants. Okay. So in exam, so they are going to ask this question. Show that pure capacitive circuit current leads voltage by 90 degree. Draw the circuit and write all these things. That's it. Okay. Next we can draw the waveforms. So draw the waveforms as neat as possible. Waveforms is very important. Okay. Now I am writing voltage waveform. So reference is voltage. So write neatly with same magnitude. Okay. So I written somewhat it is okay. This and this having both positive and negative magnitude almost at equal. Okay. So now you have to write current waveform. See, voltage is minimum. Voltage is minimum at t equals to 0. But current value is minimum. Okay. At some angle. But what should be the difference between voltage and current? 90 degree. You have to write current value 0. But the difference should be 90 degree. But what is here? You cannot write here. You cannot write current here. Because if you written here, current lags the voltage. You should write leading. So this is 90 degree plus 90 will come somewhere here. Okay. At this instant. At this instant, so current value will be 0. Okay. From this instant onwards, current waveform will going to start. See, at t is equal to 0, whenever voltage, you have to write the waveforms. When voltage is 0, you write current maximum. When voltage is maximum, you write their current 0. See here, voltage is maximum, you mark 1 point. Voltage is minimum, mark 1 point. You should write current maximum. And voltage is maximum, you should write current value minimum. And voltage is 0, you should write current value maximum. Okay, got it? So now I am drawing that. So this is the waveforms for pure capacitive circuits. So what about this part? This is the remaining part. Okay, remaining part. Since we are concentrating 0 onwards, that's why I written left side of the 0. I written with dotted lines. Okay, got it? See, current is 0 at this instant, but current leads the voltage by, what is this difference? 90 degree. Okay, pi by 2 radians. Current leads the voltage by 90 degree. Now guys, look at here. Voltage is maximum at 90 degree. Current is maximum at 0, at t is equal to 0. What is the phase angle difference between them? 90 degree. See, that will remain same. At all the instant, current waveform leading the voltage waveform by 90 degree. The meaning is, before starting voltage waveform, current waveform already started. Okay, current waveform already started. That indicates capacitor already charged. Okay, fine. Now write the equations. What is this equation? I is equal to Im sin omega t plus pi by 2. Current leads voltage by 90 degree. And what is the voltage and voltage equation? V is equal to voltage waveform Vm sin omega t. Now you should write the phasor diagram. Waveforms I written. See, don't write waveforms without knowing. Okay. In such a way you should write, when voltage is 0, write current maximum. When voltage is maximum, there you write current 0. See, voltage maximum, current 0. Okay, got it? Now, what is the reference you take an voltage? So, voltage vector you should write on the reference. So, this is the voltage. Because I take a voltage, from that voltage I determine what is current flowing to the capacitor. So, therefore, write V voltage x axis. Okay, reference axis. See now, with respect to voltage, what about current? What about current? Leads the voltage by how much? 90 degrees. With respect to voltage, okay, the current leads the voltage by 90 degrees. So, what is the angle? Positive angle. Positive angle measured in what? Anti-clockwise direction. Positive angle measured in anti-clockwise direction. However, we have to rotate the phasors, voltage phasor in anti-clockwise and current phasor also we should rotate in anti-clockwise direction. Okay, got it? So this is about phasor diagram only for pure capacitive circuit. Now we can derive what is power consumed in pure capacitive circuit. So what about power consumed in pure capacitive circuit? That we can look it over here. So power is equal to voltage into current. So what is voltage? Vm sin omega t into what about current? I is equal to Im sin omega t plus pi by 2. Now power is equal to Vm sin omega t into Im. Once again I am writing. Actually I written what is current got from the derivation. Now again I am changing this sin term. Okay, sin omega t plus 90, what I can write? Sin omega t plus 90, I can write cos omega t. So again I am writing the same equation, cos omega t. Now multiplying both, what you will get? Vm Im into sin omega t into cos omega t. Now we know that trigonometric relation sin x into cos x formula is sin 2x by 2. Now our equation is in this form, sin x value omega t. So sin omega t cos omega t is sin 2 omega t by 2. So therefore I can write power is equal to Vm Im divided by 2 into sin 2 omega t. This is the power we got. What is the frequency? Double frequency. Double frequency means what? Fluctuating component. So if I integrate the fluctuating component over one cycle, its average value always 0. Okay, we can derive this fluctuating component over one cycle. What we will get? We can check it. So integrate. Okay, 0 to 2 pi. Vm Im divided by 2 into sin 2 omega t into d omega t. So power is equal to take Vm Im by 2 outside. Vm Im by 2. What is integration of sin x minus cos x? But sin 2 omega t into d omega t. So that you will get minus cos 2 omega t divided by 2. Okay, and apply the limits 0 to 2 pi. So after applying the limits, we get Vm Im divided by 2 minus cos 2. Replace omega t by upper limit. So 2 into 2 pi divided by 2 minus, for this whole term replace omega t by upper limit, minus for the whole term replace omega t by 0. So minus cos 2 into 0 divided by 2. So then put a flower bracket. So therefore now Vm Im divided by 2 within the bracket. What is 2 pi value? 360. 360 into 2, 720. Cos 720 is 0. Cos 0. Cos 0 is what? 1. So this becomes minus 1 by 2. Then minus 2 into 0, 0. Cos 0 is 1. Minus 1 by 2. Minus 1 by 2. Therefore power is equal to Vm Im divided by 2 minus 1 by 2. Minus into minus plus 1 by 2. What happens? Okay, both will get cancelled. Off and off. Minus off plus off get cancelled. 0 into something, 0. Therefore, what you can conclude? Pure capacitor also never consumes power. Okay, got it? So this completes pure capacitive circuit. But we can check it whether we will get power wave from 2 cycles. For one voltage cycle, whether we get power 2 cycles or not, because double frequency, no? We can check it. Okay, so I am writing with green color. So multiply current and voltage waveform, something into 0, 0. Okay, now positive into positive, positive. So the power value keeps on increasing. The power value increases, it reaches to some maximum value at some instant, and again the value decreases. At this instant, power will come back to 0 because current is 0, voltage is maximum. So 0 into something, 0 only. Next, current is negative, voltage is positive. Positive into negative, negative. So because of these two values, power slightly increases. It reaches to maximum value. Again, it becomes to 0. Okay, at that instant, power will become 0. Now again, negative voltage, negative current. Negative to negative, you will get positive. So again, at this instant, power will become 0. Next, positive to negative, negative. Again, the voltage will becomes, the power waveform increases, and finally at that instant, the power will become 0. So this is what? Power waveforms having double frequency. Okay, look at here, sine 2 omega t. For one voltage cycle, how many cycles we got power cycle? So this is one power cycle and this is another power cycle. 2 cycles of power. That is called fluctuating component. So if you integrate the fluctuating component over one cycle, its average value always 0. So now multiply power into time. So now shaded portion. Now the shaded portion indicates energy stored in the capacitor. Okay. Now shaded portion in the power curve indicates energy stored. This power is having equal and opposite values, therefore power will be 0. However, we can convert this into energy term. So power waveform into time. Power into time is what? Energy. But power is 0. 0 into time, whatever the time, it becomes 0 only. But capacitor will store energy in the form of electrostatic field. Okay, so got it. So therefore, you can note down the key points. So don't compare power into time is energy. Power is 0. Pure inductor, pure capacitor never consumes power. 0 into time, 0 only. Energy is 0 only. No, not like that. It stores energy in the form of electrostatic field. So we can recover the storage charges when supply is not available. So next, look at here, observations. Pause the video and then copy down. Observations, very important, and it will be asked in Viva, and for theory it is very much required while solving problem. You must remember these points. What you can write, pure capacitor, whatever you written for inductor, same thing you write for capacitor, but all the points you should match capacitor related. So pure capacitor never consumes power. That is first point. What we written there? Pure inductor never consumes power. Next, second point. The phase angle between voltage and current, for pure capacitor circuit is how much? 90 degree. So what is the phase angle pi? 90 degree only. Pure. Underline the word pure. If it is only capacitor circuit, not 90 degree. Only pure means 90 degree. Okay. Next, number 3. So what we given number 3? The shaded portion in the power waveform indicates energy stored in the capacitor in the form of electrostatic field. That is E is equal to half CV square joules. Okay, the shaded portion in the power waveform indicates the energy stored in the capacitor in the form of electrostatic field, and that is E is equal to half CV square. Okay, next number 4. So the power factor of pure capacitive circuit is 0. What do you mean by power factor? Cos pi, cosine of the angle between voltage and current. That is the power factor definition. So next, what is pi? 90 degree. Put pi is equal to 90 degree. What is cos 90? 0. Therefore, pure capacitive circuit, okay, power factor will be 0. Okay, next, fifth one. So it looks like a phase difference concept because we have written two quantities, voltage and current. But what is the difference between them? Leading. So pure capacitive circuit is quite related to the leading phase difference. Okay, phase difference means minimum two quantities should be there. Okay, so it is what? Leading phase difference. All these points are very important while solving problems, and you should answer in Viva. Okay, got it? Fine. Next, last point. It is related to second point only. In exam they will ask a question like this. Show that pure capacitive circuit. Show that pure capacitive circuit current leads voltage by 90 degree. Like that they will ask. Okay. Next, another one. Similarly, for pure inductive circuit, show that current lags voltage by 90 degree. Out of this two, definitely any one question they will going to ask. Okay. And another question asked on this pure resistive, pure inductive and pure capacitive circuit is, show that pure inductive circuit never consumes power. Okay, show that in pure inductive circuit never consumes power. And similarly, show that pure capacitive circuit never consumes power. You have, out of these four questions, definitely one question they are going to ask. Okay, got it? So you should be prepared very well. So same logics I am going to use in upcoming circuits. See guys, we applied voltage to the capacitor, we got current this much. Similarly, if I apply current as reference, now this is the current you applied, I is equal to Im sin omega t is applied to the capacitor, then you can find voltage across the capacitor. Then you will get voltage across capacitor. If the current is reference, then voltage across capacitor is what? Voltage lags the current by 90 degree. Okay, if current is reference, a pure capacitive circuit. Okay, got it? Guys, like the video, share and subscribe, inform your friends, okay, as much as you can, okay, because exam is very near. In the month of April, 3rd week, your first exam will start, okay, 18 scheme syllabus. So start studying now only, because all the subjects, civil and electrical, are quite easy, quite difficult. You cannot study before the exam. You have to put daily effort for these two subjects, civil, electrical and of course mathematics. Okay, if you are weak in mathematics, you have to study daily. Okay guys, have a nice day. Bye bye. Meet you in next video, series oral circuit. Before starting that series oral circuit, I will explain one concept, that is the impedance concept, that is very much required to analyzing combination of elements. Okay, bye bye, take care.